Hi guys, chapter 5 video here for you. 5.3 is the section in our book if you're in our class. And the essential question that this video focuses on is, can I solve a system with another method? Now if you've been watching the prior videos, we are getting pretty good with a method called the substitution method. But I want to show you another way that we can solve these system problems, because that is not the only way. So we are going to get into our first problem today. We're going to call it example 1. And for our first example, we are going to solve this system. So here is our problem. We are going to solve 2x plus 3y equals negative 2 and 5x minus 3y equals 16. Now right away when I look at this problem, I'm not really happy with it because both of those equations are in that standard form, that there's no y equals mx plus b. I definitely wouldn't be happy if I had to graph this system. I could do it, but it's just not my favorite form. So I'm looking at this and thinking to myself, this is not a good choice for substitution. There's no isolated variable. I do not see an x all by itself or a y all by itself. Usually substitution is great when it says like y equals something or x equals something, and that's not here. We don't have that. So substitution, I'm going to cross that out and think that is not my best option. So let's go for a different option. I'm going to teach you a new way to do this. We're going to go back to some old traditional math, back to elementary school. Remember in elementary school when you were learning how to add and subtract, and you would draw the line underneath and put the little addition sign? That is exactly what I'm going to do with this problem. I'm going to draw a line underneath and put an addition sign. We're going to add this problem together. Watch what happens when we add it up vertically. 2x plus 5x is 7x's. 3y plus a negative 3y, what happens there? A 3y plus a negative 3y? Oh, that's 0. Those are going to eliminate and cross out. They go away. And then negative 2 plus 16 would have to be 14. So look what I end up getting. I still have the equal sign. I shouldn't forget the equal sign. And I have 7x equals 14. That's super easy for me to solve. I'll just divide the 7 away and I've got my answer. X is equal to 14 divided by 7. That's 2. So there it is. X is equal to 2. There's our solution. See how nice and simple that was? Now it only worked this easily because everything vertically lined up. But in that standard form, that's kind of what happens. Now don't forget, we're not totally done. We have not solved for y yet. We need both variables. So I still need to do a little bit more work. I need to solve for y. And to do that, I got to go back, pick one of the equations, one of the original equations. So either the 2x plus 3y or the bottom one, the 5x minus 3y. Either one's going to work. I'm choosing the first one. 2x plus 3y equals negative 2. I'm going to write it back down, copy it back down. And now that I know what x is equal to, I think x is equal to 2, I'm going to put a 2 in there and replace it. So instead of 2x, I'm going to have 2 times 2 plus 3y equals negative 2. And we're going to put that 2 times 2 together and we're going to make that 4. And 4 plus 3y now equals negative 2. Think of this as like a line down the middle. We're going to get y all by itself. So take that 4 away to the other side. Negative 2 and negative 4 are going to give us a negative 6. And then if we have a 3y, we'll divide the 3. And we're going to get a nice negative 6 divided by 3, which is a negative 2. And we got our answer. X is equal to 2, y is equal to a negative 2. So on the graph, our point of intersect, if we were to graph these lines, is at the point 2, negative 2. And there you have it. Now, this is a pretty cool method. I actually find it a little easier than substitution. Of course, it only works if you have 2 equations in standard form that line up, but it's pretty speedy. So let's try another one. Let's do an example 2, because they don't all look the same, of course. So we're going to solve this system. We're going to try a new problem. We're going to solve 2x plus 7y equals 13. And we're going to solve 2x plus 3y equals 5. Now remember, we're using like old school addition. So if I put a line underneath and I go to add this up, here's what's going to happen. 2x plus 2x makes 4x. And 7y plus 3y makes 10y. Now we got a problem. Last time when I did this, the y's canceled out. They eliminated and went away to 0. Didn't happen this time. I still have an x and a y, which means I can't solve this problem. This is an issue. I'm going to write that down. The problem is no variable eliminates. No variable goes away. We want either the x to disappear or the y to disappear, and that didn't happen. So I'm going to fix this problem. I have a new idea. Let's put a line under it, and instead of adding, let's subtract. What's 2x take away a 2x? Ah, there we go. 2x take away a 2x is 0. Now we got an elimination. This is what I wanted to do. But now I got to subtract everything else also. So 7y take away 3y is 4y. And 13 take away 5 is going to be 8. So you get this nice 4y equals 8. I don't know why that line on the screen was a typo. Sorry about that. We're going to divide the 4 away. Now the 4's cross out. And 8 divided by 4 is 2. So there's our answer. Y is equal to 2. Awesome. Now we're not totally done. Don't forget, we got to solve for x. We need both answers. So I'm going to solve for x quickly. I'm going to go back and recopy one of the first equations. So I'm going to pick the 2x plus 3y equals 5. And then what I'm going to do is I'm going to copy that down, and I'm going to replace y with my answer 2. So instead of 3y, we'll have a nice 3 times 2. And then I'm going to have 3 times 2 is 6. So I have 2x plus 6 equals 5. Line down the middle, let's solve for x. We'll take our 6 away. We'll have 2 x's left, and we'll have 5 take away 6, which is a negative 1. And then we'll divide our 2 away from both sides. This is math we all know how to do, so we're pretty fast at this now. And we're going to get x is equal to negative 1 divided by 2, which is negative 1/2. If you want to make it a decimal and call it negative 0.5, that's fine too. Decimals or fractions work. But here's our solution. Our point of intersect on the graph will be at negative 1/2 and 2. Negative 1/2 and 2. Awesome. All right. So now that we have our solution, you've seen that sometimes adding works great and sometimes subtracting works great as our method. Let's look at this one, example 3. We're going to solve this system. Here it is, x minus y equals 2, and y plus 2x equals 1. I might challenge you to pause the video and look at this problem carefully. Do you see how this problem is different than the last two examples? Can you see it? What's different about this problem? I hope you're noticing that the x's and the y's do not line up. They're not under each other vertically. We don't have them lined up. That's kind of a problem when I go to do my adding and subtracting. So here's what I'm going to do. I'm going to draw an arrow over, and I'm going to rewrite this problem. Instead of x minus y, I'm going to change it to negative y plus x equals 2. Mathematically, that's the same thing. I haven't changed the problem. I'm just switching it around so that when I take the bottom equation and rewrite it the same, I'm not changing the bottom one, y plus 2x equals 1. Now the y's are lined up, the x's are lined up, and the numbers are lined up. It's in the right order. So now I'm ready to do this problem. So I'm going to put a little note for our notes off to the side. I'm going to say we needed to rearrange to line up the equations. That's your job to figure that out when you get these problems, is to figure out how to line them up vertically so they work. Rearrange them. Now I can add this up and it's going to be no problem. The negative y and the positive y are going to eliminate, which is what we want to get our 0. X plus 2x makes 3x, awesome. And 2 plus 1 equals 3, so I get 3x equals 3. Easy, we'll divide the 3 away and we're going to get a nice answer of 3 divided by 3, which is 1. Awesome, x is equal to 1. Don't fall for the trap. People often do this, like on a test, they'll be hurrying through problems and they'll stop here and they'll think they're done because they've solved for x, but don't forget to solve for y. So I'm going to solve for y real quick. I can pick any of the first equations, so I'm going to go back and pick this one. Y plus 2x equals 1. I'm going to change my x to a 1, and I'm going to make it 2 times 1, so instead of 2x. So this will be pretty fast. 2 times 1 is 2. So I have y plus 2 equals 1. Line down the middle, this is a quick solve. I'll just take that 2 away and I'll be done. Y is going to equal 1 take away 2, which is negative 1. And there's our solution. So these are two lines on a graph. that will cross at the point 1, comma, negative 1. That is our x and y value, 1 and negative 1. And we've got our solution. So to wrap up this video, we call this the elimination method. It's the elimination method because we are eliminating a variable. We're getting rid of x or we're getting rid of y. We're eliminating them. So some important things, you should write this down. Some important things about the elimination method is it's an algebraic strategy, meaning it's a way to avoid graphing if you don't want to graph. You can solve a system other ways. You don't have to graph. You can use this algebraic strategy. Both equations typically need to be in standard form for this to work. So if you get two standard form equations, then you line them up vertically for this. And really, it uses this traditional addition and subtraction. Think back to elementary school when you put the line underneath and you add it up vertically or subtracted vertically. It's that same strategy. And then this is pretty important. One of the variables must eliminate, hence the name elimination. If you can't get rid of an x or a y, then you're still stuck and you can't solve the problem. So you've got to eliminate and you got to choose if adding or subtracting is the better strategy. And that is the elimination method. Now, I got to say, they do get more complicated, so there's going to be more videos because we're going to build up the level of rigor with these problems. But I hope you were able to follow and understand how this works, and I hope in class you can kind of apply it. Thanks for watching, guys. Have a good day.